This is the final homework practice set for this unit. Yay. So this is a continuation basically of the last page. This is just, there's more, what do you call it? Dilution questions though than before. So before there was not many cases where you had to do a dilution, but this case there is. And so therefore, let's look at 33. So 100 milliliters of, okay, let's write this out. Lead nitrate. So we're gonna fit all of them on this page. Lead nitrate plus. So this was 100 milliliters or 0.1 liters, and 1 times 10 to the power negative 3 moles per liter. Sodium chloride 40 milliliters, 0.04. milliliters is equal to 0.04 liters and 0.04 molar concentration as well. Okay, we strictly don't really need to complete this reaction. Let's just do it for the sake of doing it. 3, need a 2 here and a 2 there. And again, in terms of, it really doesn't matter what this equation is. All I know this equation is telling me is I'm looking for this solid of lead chloride. So that's going to be my dissociation equation right here. And so I have to find, again, I'm looking for QSP, which means I have to find initial concentration of lead 2 plus, initial concentration of chloride minus, which I obtain from these two, because the lead is coming from here and the chloride's coming from here. So I need to find, I need to basically look at those two. So the lead concentration is equal to the lead nitrate concentration, which is equal to 1 times 10 to the power negative 3 moles times moles per liter times 0.1 liter. So this is the number of moles, and a dilution factor of 0.14 liters, because I have diluted this by adding 0.04 liters of another solution. And if I put that in my calculator, divided by 0.14, I get 0.0000714 mole per liter. Chlorine ion is the same as my NaCl concentration, which is 0.04 times 0.04 divided by 0.14. See what that is. 0.01143 something. So I'm going to put those values in here. My lead was the first one, so 0.000714. Chlorine was 0.01143. Note that the 2 here does not affect my initial concentration in any way, shape, or form. The initial concentration is something I get from the question. Admittedly, I had to do a little bit of calculations to get this, but it was given to me in the question because of this. It did not require, I don't have to multiply this by 2 at all. What I do have to do now, although, is QSP. I take lead concentration times the chlorine concentration squared, because that 2 does affect the square. So I'm going to square that, multiplied by 0.000714 gives me 9.325 times 10 to the power negative 8. So let's look at the KSP of lead chloride, which I will look at the back of the textbook for. Chloride, lead chloride is not given. I could have sworn lead chloride was supposed to be the precipitate, but I do not see a Interesting. I do not know the KSP for lead chloride. I am stuck. I don't see it anywhere here. I also don't see it at the back of the textbook. So you're at an impasse, it seems. I'll just say, I feel like we've done a lead chloride question somewhere here before, but we're just going to leave this blank and say if the QSP is lesser than KSP, that means there's not enough of these ions, which means there will be no precipitate formed because the reaction will favor the right because there's not enough of the right. If QSP is no precipitate, if QSP is greater than KSP, that means there's too many ions, which means to counteract that, the reaction will shift left, forming a solid precipitate. So yes, precipitate. And of course, if QSP is equal to KSP, that still means that there's no precipitate as we are at saturation. So there's no precipitate formed. Okay. Next question. The KSP is given, so I like this question. AgNO3 calcium acetate. Never mind, I don't like this question. Let's write acetate ions. AgNO3 200 0.23 0.0015. AgNO3 0.23 liters 0.0015 molar. Calcium acetate 0.13 0.1 0.01. Calcium acetate 0.13 liters 0.01 moles per liter. Again, we know that our interesting precipitate here is the silver acetate, which we need to break down. So we're going to break down silver acetate into its ions, silver plus acetate minus. We'll have a good 1:1 ratio. And then let's calculate our concentration of silver plus. So the silver comes from my silver nitrate and therefore is equal to the concentration times the volume divided by the total volume, which is 0.23 plus 0.13. Hopefully this is a dilution that I'm doing. Again concentration times volume divided by the volume to get a new concentration. So that gives me 0.000953 concentration of acetate ions. Here is the trick, is going to be 2 times the concentration of calcium acetate, because each calcium acetate gives me 2 acetate ions. So the concentration of acetate, so if there's like 1 mole of this, I technically get 2 moles of acetate ions. So therefore I have to multiply it by 2. So it's 2 times 0.01 times 0.13 divided by 0.23 plus 0.13. This part remains the same. I'm still doing concentration times volume divided by total volume to give me a new concentration. 2 times 0.01 times 0.13 divided by 0.23. That gives me 0.0072. So I'm going to put these values in 0.009583, 0.0072. My QSP is going to be just the concentration of silver times concentration of acetate, which just means I'm multiplying these two numbers here. So times 0.000953, which gives me 6.92 times 10 to the power negative 6. And I seem to recall that my KSP was very high compared to this. So QSP is lesser than KSP. Therefore, no precipitate will form because, again, KSP is at saturation, so even at KSP there'll be no precipitate because there still isn't enough ions to satisfy, if you will, the equilibrium condition. So the equilibrium condition is this KSP value. My QSP is too low, which means I don't have enough ions. That means I will any addition of even a solid or any addition of more silver and acetate will still remain in the ion form and not form a precipitate. So the solid precipitate will not occur. All right. Sodium hydroxide, cobalt chloride, 25 ml, 0.1 mole per liter. Sodium hydroxide. Cobalt chloride. 0.5 0001. Okay, we know that our interesting sodium chloride is uninteresting. The interesting thing is cobalt hydroxide. So we're going to write a dissociation for cobalt hydroxide. Let's check if there is a KSP given. Excellent. Back of the textbook, 5.92 times 10 to the power negative 15. Well, there's not one given here, so we're going to go with the back of the textbook. 5500. Yeah, well, this looks good. Does a precipitate form. Okay. So again, initial concentrations of cobalt and hydroxide are what I need. So initial concentration of hydroxide is same as the initial concentration of sodium hydroxide, which is 0.1 concentration times 0.025, which is the volume, which gives me number of moles, divided by my total volume, 0.525. .0047. Yeah. Concentration of cobalt equals concentration of cobalt chloride is 0.0001 times 0.5 divided by 0.525. 0.000095. So we're going to put these concentrations in here. 0.00. So my QSP is cobalt concentration times hydroxide concentration squared. Hydroxide concentration squared, so let's do that. Which is equal to 2.16 times 10 to the power negative 9, which is greater, in fact, than my KSP. Therefore, again, so these ion concentrations are too high because my QSP is too big, and therefore this equilibrium will shift to the left where my solid is, therefore precipitate will form. Is my answer. Last one. 250 milliliters of aluminum sulfate, 0.0011. Let's see. Aluminum sulfate. What is that added to? 50 milliliters of barium chloride, 0.022. again, the one I'm interested in is probably my barium sulfate, although I'll double check that. Yeah, barium sulfate is insoluble, so we're guessing aluminum chloride is soluble. So barium sulfate, solid, plus aluminum chloride, aqueous, I'm not worried about. So my KSP expression is going to look something like barium sulfate, barium 2 plus, SO4 2 minus, QSP, well, let's write let's not hurry. I do know, though, my KSP for this expression is going to be equal to, where is it? I just had it. No, 1.08 times 10 to the negative 10. Interesting. I'd like to guess whether this actually forms a precipitate or not. I'm going to say, what do we have so far? Will form, yes precipitate, no precipitate, yes precipitate. Let's see if the textbook follows a pattern. I'm going to guess no precipitate, and we'll see. So again, concentration of sulfate is equal to 3 times concentration of aluminum sulfate is equal to 3 times concentration times volume divided by total volume, which is 0.3. It's 25 plus 0.05, right? The total volume. So 3 times 0.0011 times 0.25. 2.75 times 10 to the negative 3. Concentration of barium equals concentration of barium chloride equals 0.05 times 0.022 divided by 0.3. The same expression at the bottom here. So 0.05 times 0.022. 0.0036. So I'm going to put those initial concentrations here. 2.75 times 10 to the negative 3, 0.0036. Let's multiply those. QSP is 1.008 times 10 to the negative 5, which is greater than KSP. Alas, our prediction was wrong. Precipitate will form because my QSP is greater, right? And my QSP is greater, that means I have too many ions. These numbers are too big, so I will shift to my reactants where the solid is. So shifting to reactants means forming the precipitate. Okay, so that was the last homework. I will post the answers to the review will come soon, and then you can check all of that, and then should be good for your test. All right, see everybody in class.